Okay, so here's what happens when you run a program. You're going to type the program into the computer, and we're going to use a software called Visual Studio to type it in. And when you get it all typed in, you're going to do something called Build It, and Build It sends it to the compiler. The compiler is software that checks to make sure that you typed in everything correctly, that you didn't make a syntax error, you didn't type something in wrong, you didn't forget something. The compiler will tell you either you made a mistake, and it will tell you, it will try to tell you where you made the mistake. Visual Studio is pretty good. It'll tell you which line number your mistake is in usually. Or if you didn't make any mistakes, it will build. It will build the object file, and this is in the format binary. This is actually the actual machine language that the computer can run. It will also create something called a linker. The linker, when you create a program, quite often you're calling in other programs. The linker combines it all together, and it'll put everything together to an executable file. It'll run. If everything runs correctly, your program works and you're happy. So that's basically what happens when you're in lab and you go build, run without debugging. That are the codes we'll use in class. Some of you saw that this morning. Some of you will see it this afternoon. All this stuff is happening in the background. All you see is I typed stuff in. Either I get an error, I did it wrong, or it runs and I'm happy. But a lot of other stuff is happening in the background, okay? Questions about that? Okay, so that's the basics of how a computer works. Now let's talk a little bit about data and data types. A computer program operates on data. Data is stuff that is stored in the computer. It's stored in memory. Memory can be different forms. You can have memory within your computer that it could be stored in. It could be stored on a disk. It could be stored on a flash drive, so on and so forth. When you're dealing with C, you have to specifically define every variable and tell C what data type it is. In other languages, you don't have to do that. In other languages, you can make up variable names and just start using them right away. You don't have to tell the computer, is this going to be a decimal? Is it going to be an integer? Is it going to be a letter? The computer will figure it out as it goes. In C, that's not the case. At the beginning of every program, you have to define every variable, and you have to specifically tell the computer what kind of variable it is. Okay, so when we're dealing with numbers, there are lots of different types of variables we can use. There are integral variables. What's integral? In math, what does the word integral mean? Could mean function, could mean something else. I want it to mean something else in this case. Ooh, that's another good definition of integral, but again, that's not the one I'm looking for. How about think of it as the word integer instead? What does an integer mean in math? Positive or negative? Like a half? A whole real number? Greater than zero? Could be negative? Could it be zero? All right, so the integers are 0, 1, 2, 3, 4, 5, so on and so forth, plus -1, -2, -3, -4. They're the nice numbers, the numbers you like to deal with. They're not fractions, they're not decimals. So that's what integral means in this case. Could it be what? No. An integer variable is one number, and one number only. All right? There are different kinds of integer variables in C++. There's an integer variable called short. There's an integer variable called long. There's an integer variable called int. There's an integer variable called enum, which can be made unsigned, which means it could only be positive. Why do we need different kinds of integers? If the integers are 1, 2, 3, 4, 5, why do I sometimes want to call it short? Why do I sometimes want to call it long? Why do I sometimes want to call it int? That's true, and that will happen, but that's not why we have different kinds. Correct. That's the exact reason. So what she just said is this. If you use the variable type short, then your number needs to fall between negative 32,767 and positive 32,767. Right. For an integer, I don't know what you mean. Okay. Well, it'll make more sense in just a minute here. Typically, when I'm writing C++ code, if I want an integer number, I define it as an int type. And you'll notice int types can go between roughly negative 2 billion and positive 2 billion. So I figure if I'm using a number, it's most likely going to fall between negative 2 billion and positive 2 billion, so I figure that's pretty safe. And then there are other ones. So I don't know why we have long, because long has the same range of values. I don't know how long is different from int. I don't know, but they are somehow. Okay, so typically, if you want an integer number, you're going to use variable type int. Well, the way negative and positive is dealt with, that's okay. In memory location, when you define a variable, it saves a block of memory on your computer. And it saves so many bits, so much memory. The very first character that it's saved determines if it's positive or negative. So in the first slot of memory, it determines positive or negative. And the next several slots is where it actually saves the number. Go ahead, Brian.
Correct me if I'm wrong, but the first slot would either be positive or negative 0 depending on the terms. And alternate or
actually, when you get right down to it, the computer either puts a 1 or a 0. And truthfully, I don't know which one stands for positive and which one stands for negative. So in that first memory spot, it either puts a 1 or a 0. I don't know which one. And the computer interprets, well, I'm going to say it's 1. The computer interprets 1 as saying this is a negative number. And then it stores the rest of the number later on.
The reason we classify types is because that makes it easier to say that our
Correct. So part of the reason we use different types of variables is to save memory. So probably for the programs I write, I really probably should be using short type. Because very rarely am I writing programs that have numbers that go more than 32,000. So I really should use short because it would use less memory, and using fewer resources is good because then your computer runs faster. But I use int because int always makes me think integer. And so I always use the int code.
So does that mean we can apply to both short and long variables?
Correct. All right, so in C++, let's say you want to define a variable. We want to define an integer type variable called, somebody give me a name. What do we want to call our variable? S. That's a terrible name for a variable. All right. In this class, we will never, ever, ever, never use single letters to represent variables. A variable should be a name that describes what you're using it for. So if you write a program and your variable name is S, I will take points off, I promise. Okay? It can be what? Yeah, what do you like? Give me a name. Sure. Fred. So we're going to call our variable Fred. Okay. The rules on variable names. The first letter has to be a letter. The first character has to be a letter. After that, you can have numbers. And you can also have some special characters. Don't ask me, Robert, off the top of my head which ones, though. Normally, I would want to call it something that describes what it's going to do. For example, if I was writing a program that computed area of a rectangle, I would probably call one of my variables area, I would call one of my variables length, and I would call one of my variables width. So normally you would give them names like that describe what they are. XMPLE, for example, that would be okay. Yeah. All right, so if I want to define an integer type variable called Fred, in C++, like I said, I always use int, and then you're going to have a space, and then you give it the variable name Fred. And then in C, at the end of almost every line, you're going to have a semicolon. So what this is going to do, the computer, when this program runs, the computer is going to say this and say, okay, right here, the person's telling me, save some memory. Int says, I'm going to make a variable. Save some memory. And anytime I see the word Fred, it tells me to access that memory spot. Okay? Make sense? Different programs have different ways to indicate when a line of code ends. Some of them use a hard return. Some of them use semicolon. In Fortran, you had to number every line. So every time there was a new number, the computer knew it had a new line. So the computer just needs to know when one line of code ends and when the next one starts. And different languages have different ways. In C, it's a semicolon. In Java, it's a semicolon. In Pascal, it's a semicolon. Semicolon is a very common one. Okay? All right, so what kind of numbers can I store in Fred? Integers, that's correct. What if I try to tell the computer that Fred is 2.5? It will make it 2. It will truncate. So if later on in my program, I try to say Fred equals 2.5, the computer will actually accept that. However, the number 2 is stored in Fred.
As all this random thing, isn't it underlying all kinds of stuff, make a mistake? How does it not catch that?
It doesn't catch it because it's not an error. It can run it, and it will give you an answer. It doesn't give you the answer that it wants, but it will accept that. No, because if you plug 2.5 into an int variable, you're not going to get the answer you want. You really made a coding mistake. So this, in computer programming, we would call this a runtime error, which means it works. The computer gives me an answer, but it doesn't give me the answer that I want. And that's the worst kind of error because they're really hard to find. Right. You could, but we don't. We won't in this class anyway.
So is it always just move like even if that was 2.9, it would just call it 2?
If this were 2.9999999, it would still call it 2. It truncates. It just cuts it off, slices it off. Yep. Doesn't round up. It always just cuts it off. Called truncating. All right. Now, what if? Completely different thing. What do you think that line would do if I wrote in C++ int num1, comma, num2? It defines two variables. So it's now telling the computer I'm saving two memory spots, and one of the memory spots I'm going to call num1, and one of the memory spots I'm going to call num2. So if you need to define a whole bunch of integer variables, you can do it all in the same line. It doesn't matter if there's spaces or not. You just need a comma in between them. If you put spaces in between them, it will just ignore the spaces. Oh, so that was something I was talking about. For variable names, they have to start with a letter. They can have numbers in them, so I can use num1. But there can be no spaces in a variable name. So if I tried doing int num, and then I had a space and a 1, that would give me an error when I tried to compile my program. That would not work. Not valid. Also, C++ is case sensitive. So if I write int num1, comma, num1, in C++, those are different variables. So this is one variable called num1 with a little n, and this is a second variable called num1 with a big N. And it treats those as different. So it is very case sensitive, so watch out for that, because sometimes I'll see people type, they'll declare their variables with capital letters or not, and then later on they try to use it and they switch it. Sometimes they have capitals, sometimes they don't. That's not going to work. They have to all be exactly the same. Okay? All right, so that's a little bit about integer variables. What if we want a decimal? Sometimes we deal with decimals, right? What do we do then? All right, so there are different kinds of decimal variables. And again, there's different kinds because of memory allocation things. There's float. Float will take any number between 10 to the negative 37 and 10 to the 38. So it goes really, really teeny. You know, it can have 36 zeros and then a number, up to 10 to the 38th. I have no idea what that is. Billions upon billions. And it saves 6 significant digits. On the other hand, a double, which will also give you decimals, doubles can go between 10 to the negative 307 and 10 to the 308, and they will save 15 significant digits. So again, what kind of variable do you use depends on what you're writing the program for. Again, for most of what you're going to do in this class, in fact, I absolutely positively guarantee that all your numbers will fall between 10 to the negative 37 and 10 to the 38. If they don't, you made a bad mistake. You will not have any numbers that small or that big. So if you're writing a program and you know your number is going to fall in that range and 6 significant digits is enough for you, then you use float, because float uses less memory. Again, uses less resources. If you need a number with a wider range, or if you need more significant digits, then you would define your variable as a double, and it would save more space. Okay? The declaration is exactly the same. So if I want a decimal variable, I might use the word float, and then I give it a name. Anybody got a new name for me? Steve? All right, we're sticking with boy name. Capital S or little s? Oh, I already wrote a little s, too late. S-T, big E though. Steve. Why a big E? I don't know. Just to be different. So again, what this would do, in memory, this would save a location for a decimal variable, and the decimal variable's name would be called Steve. And again, every time you used Steve, you would need to make sure you put that big E in there. Otherwise, it won't read it correctly. Same sort of deal. You can go double, and then you can go decimal 1, decimal 2, decimal 3, as many as you need, decimal 4. So let's say you needed a program with 4 decimal variables. You might call them decimal 1, decimal 2, decimal 3, and decimal 4. That will create 4 variables, save place in memory, and the computer will know these are going to be variables that you can type decimals into.
Do you use this if you're trying to find
Right, so, again, in this class, we won't have anything that requires more than 6 significant digits. So in this class, we would probably use float for everything. Again, I don't know why, it's just a habit I got into. I typically use double. I don't know why, I just do.
Like with the variable 10.0, all it has to value is 10, you still want to use 10. So, this is defined by 0.
Correct. So if you're worried about significant digits, like if you're in a physics class, then you would want double decimal 1 equals 10.0. So this is going to do two things. A line like this will tell the computer, save some memory location, call it decimal 1, and at the same time plug in 10.0 into that memory spot. So sometimes you want to define variables, and this is called initialize them at the same time. So this sort of line up here, this is called a declaration, where we declare our variables. A line like this is called declaration and initialization. I don't know if I can spell that. Close enough. Initialization. So again, what this would do is this would create a variable called decimal and stick a number into it. However, it's not always going to be 3 significant digits. I could store a different number into there that has different significant digits.
So when you really begin to develop program, you can't deliver stuff that double that speed up the runtime.
Absolutely. Within programs, you will have some variables called integers, and you will have some variables called doubles or floats. Absolutely, you will have both kinds within a program.
No, it's not a reasonable that we did our quotient.
All right, so what he's talking about is when you use integer type variables, you need to be very, very careful if you're going to use division. So let's say I do int num1 equals 6, and then I do another line that says int num2 equals 4. And then I'm going to make another variable called quotient. And then, somewhere in my program, I'm going to have quotient equals num1 divided by num2. All right, so this might be a little block of a program. Int num1 equals 6 do. It declares the variable num1 and initializes it with the number 6. So num1 is now the number 6. Same thing, num2 is the number 4. Int quotient. So this is an integer type variable. I called it quotient. So what happens, what does the computer do when it sees quotient equals num1 divided by num2? What's 6 divided by 4? It should be 1.5. 1.5. But the quotient is actually going to be defined as 1. That is correct. So when this runs in C++, a double line like this means I'm going to write some documentation to tell you what this does. When this runs, quotient will be the number 1.
That same line of
All right, so his question is, different program. What if I had int num1 equals 6, int num2 equals 4, float quotient. And then quotient equals num1 divided by num2. All right, so the only thing I changed is quotient is now a float variable, which means quotient can take decimals. So now, when I say quotient equals num1 divided by num2, what value gets stored in the quotient? Unfortunately, it's still the number 1. Because num1 is an integer. Num2 is an integer. It divides these, it gives the answer as an integer, even though the answer that it can store into is not an integer. So unfortunately, this still doesn't work. Quotient will still be 1. If I divide two integer numbers, it's going to give me an integer number always. Even if I'm telling it, store it into something that's not an integer. So you need to be very, very careful when you use integer variables and you do divide. So how do we fix it? All right, there'd be two options. If I first define num1 or num2 as floats, or both, as long as one of them is a float, when it does division, it will give a decimal. Or the other option is to do this. Quotient equals double num1 divided by num2. You have to tell the computer to treat at least one of the variables as a decimal. I chose num1. Yep, so it's double, and then you need the parentheses. And then tell it to divide. And now, quotient will be the right answer. If they're all double from the beginning, then you have nothing to worry about. Because if they're double from the beginning, when it divides, it'll say, okay, it can be a decimal, and it'll give you the decimal. Correct. So we use integer types because they use less memory, and it will speed up runtime. In this class, yes, because our programs are going to be short enough that in reality, we're not going to have to worry about how fast does our program run. But I will tell you, professional programmers who look at your code would be very upset with you for using doubles when you shouldn't. And again, if you ever do a large amount of computer programming, again, my son at the University of Buffalo, when he submits his program, not only does he get graded on is it right or not, but he actually gets graded on how fast it compiles and how fast it runs. And we're talking microseconds. The difference in microseconds between his program getting an A and his program getting a B. So efficiency is important. For us, our stuff's going to be short. It's really not going to matter long run.
What about repeatability and cost?
C is a very standard program, a very standard compiler. So if you write C on one software, it's almost guaranteed to compile on a different C compiler and run. Almost guaranteed. Nothing's completely guaranteed, of course. But there is also readability, and that's important to us too. So, if we want something to be an integer, and it's important for it to be an integer, then we really should declare it as an integer, even though it may cause problems later on. All right, so let me tell you one place where people always run into issues with this. And I've seen this mistake many, many times. In C++, there's a way to do exponents. And to do exponents, there's a command called power. And so it looks like this. So power 5 comma 2. Well, I would need to set that equal to a variable, I guess, so I'll call that num1 equals power 5 comma 2. So, any guesses as to what power 5 comma 2 does?
5 squared.
That's 5 squared. So this line is going to take num1 and set it equal to 5 squared, which is 25. That's not a problem. Problem is, what if you want to do a square root? How do you do square roots? All right, so there's two options. So num2 equals power, I'm going to use a nicer number, 9 comma 0.5.
5, 1 square root of 5.
All right. So this line right here is going to do 9 to the 1/2, which will give you the answer 3. It'll give you the right answer. Here's the mistake people make. They'll do num3 equals power 9 comma 1/2. And the problem is, C reads this and says 1 is an integer, 2 is an integer, so what's 1 divided by 2? 1 divided by 2 is 0, because those are integers. And so this is actually going to do 9 to the 0, which is 1. Very, very common mistake that people make. The good news is it's very, very easy to fix. The way you fix it is you go num4 equals power 9 comma 1 with a decimal point divided by 2. So now the computer says this thing is the number 1, but it's not an integer, it's a decimal. So now what's 1 divided by 2? It's really the 1/2 that we want it to be. It's 0.5. So watch out for that. That's a very, very common mistake, and people wonder, well, how come my program's never giving me the right answer? And it's because somewhere you used a 1/2, and you'll see it. I'll see it in things like this too. Finding the area of a triangle, people will write area equals 1 divided by 2 times length times width. And the computer will always tell them the answer is 0. Why will the computer always tell them the answer is 0? Because 1 divided by 2 is 0, and I multiply stuff by 0, I get 0. That's correct. So again, if you're going to use fractions, get in the habit of putting a decimal point right there. And then it will work correctly. It will recognize, oh, he doesn't want this to be 0. He wants it to really be 0.5. Okay, so watch out for that. Very, very easy mistakes to make. I promise I will probably make it somewhere throughout the year. It just happens.
Okay, you're saying that if you just put 1 without a decimal point, that is 0?
1 divided by 2,
Oh, 0.5. Now,
which is 0.5, but this is an integer, so the computer is going to truncate it and call it 0. So in C programming, 1/2 equals 0. Where 1 point, like you want, 1 decimal point divided by 2 equals 0.5. So watch out for that. Very, very easy mistake to make. Right. Yeah, and the problem with this is the computer's not going to read that there's any mistake here. It's going to compile everything, it's going to run the program, and it's going to give you the wrong answer. And that's the worst possible situation. When the whole program runs, when it gives you the wrong answer, that's a bad thing, because first off, you might not even know you have the wrong answer, which is bad. Secondly, if you realize you have the wrong answer, you have no idea where it is. And you have to go by line by line by line and check, and it's a real pain in the neck. Not that I'm aware of. You'll get the habit of it after a while.
Some point in support of the project, radar also programs
Well, no, I will always tell you what to write. You will be writing your own programs, absolutely. That'll start next week. Tuesday in lab next week, you'll be writing your own program. But I will tell you exactly what I want the program to do. So you don't just get to write, a new Space Invaders game or something.
I actually just think of a program.
Okay. That could be interesting. All right, so anyway, we talked about integers, we talked about decimals. Other kind of variables you can have is you can have characters. Sometimes you might want to save a letter. So a character variable is called ch. Letter. So this is called a character variable. And it stores exactly one thing. It could be a letter, it could be a symbol like the @ sign, it could be a number, but it treats it as a letter. If you have a character variable, you can't do math with it. Even if the number 7 is stored to it, it's a character. You can't add to a character. So this saves a single letter. Unlike a string type variable allows you to save a number of letters. And it's a lot. I don't remember how many things you can have in a string variable. So you might use string, for example, if you wanted to save somebody's name. If you wanted somebody to type in their name, you would most likely use a string variable. Okay, so this would be multiple characters. We'll talk about that more. All right, so I think we've talked about everything except the last thing. Sometimes in a program, you might want a constant. For example, you might be writing a program and you need to use the number pi over and over and over again. The number pi is not automatically defined in C++. If you want the number pi, you would have to define it. So to define a thing like that, a constant, something that's never going to change, it's very similar. You write the word constant, const, and then you tell it what kind of variable it is. So if I want pi, I would want a double. And then I give it the name, pi equals, how much is pi? That's as many as I know. That one's a 6, but the next one rounds up to it. And the next one's a 5. All right, so what this would do is this would, again, create memory location, a decimal memory location. It would call it pi, but this thing out front tells the computer within this program, this value of pi can never change. So pi is always going to be 3.1415927 within this program. It can never change. Okay, or you might have something like const int, I don't know, 12 equals 12. So again, it says memory location, calls it 12, it's an integer, and it can never change. Yes, but not in this class. What she's talking about is sometimes you write very specific programs that are called libraries. And what a library usually has is a bunch of commands that you use over and over and over again. And then from the program you're using, you call in this library so that things are there. So yes, absolutely, you can do that in C++. We will use some libraries that are predefined for us, but we will not be creating any of our own libraries within this course. But absolutely, that can be done. Other questions? Right. A character, when you use a character type variable, you can call it, the same rules apply. The name has to begin with a letter. It can have numbers in it. It can have, for example, you could do CH, first initial. So you could have a variable named like that, where this is an actual dash. So this will store one letter. So if I were using this, my first initial, I could store to that variable, my first initial, I could store G. A string variable, on the other hand, I might have a string variable called first name. Good timing, my pen's dying. And in that, I could store my whole first name. So that's the difference between a character variable and a string variable. A character variable literally holds one character, one and only one. Where a string variable, you can put multiple things into it and it's all saved all in one spot. Okay.
Can you manipulate strings anyway?
Yes. Yes, there is a way to manipulate strings. What he's talking about, manipulating strings. If I have a string and all I really want to know is the third character, is there a way to get just the third character? Yes. Or if I want the first and last, is there a way to do that? The answer is yes. We will not do that in this class. We will use string variables only to store things like names and then dump them back out. So the amount of programming we do in this class is actually pretty limited. We start this class assuming that you have never done any programming before in your life. So how far we get is pretty short. If you were to take C programming across campus from the computer science department, you would actually cover significantly more than we do. You would get into string manipulation. You would get into the plus part of C programming, and so on and so forth. We don't have time to get to that, unfortunately. Other questions, comments, concerns?